Hey yo, what's up? YouTube, it's your boy JOSHABRAHAM. Eh. And we're back with the general chemistry. And if I remembered, after today's class, we already reached, at least today's class, the professor already reached page number 170 or somewhere. No, bro. Not right now, bro. Not this one. It was about redox reaction. I remember that. Yeah. So it's about page number 180. So it is past half. We have gone, like, the total number of pages is 302, and we're at page number 180, or past 180, which is more than half. So that's cool. Where did I reach? I was about I was about page 40 or 70. I don't think it's 70. I was difference between rows and columns. No, with yeah, wave number, wavelength. Yeah, somewhere here. Yep, exactly here. That's where I was last time. $14. Oh, why is it so dirty? Like, why? What made the cover so dirty? What is it, child? No, that's not. That's not. It's not doing anything. Is it my fingers? For real? For real? Okay. Do I need the jacket? No, but it's pretty cold. Where is this good guy? I saw your exams are in I saw your exams are in German or English. It's oh whoa OBS, did you just crash? OBS just crashed, people. Yeah, my exams are in English, so that's a good thing. Do I speak German? I wouldn't say I do. I wouldn't say I speak German as fluent as I should be speaking, because my German is nowhere close to get me a job. I know the basic terms, the basic stuff, but I should learn German. The No, what the OBS? What is wrong? What is wrong with you, OBS? I don't get it. Why are you suddenly not working? Okay, now it's working. I mean, there's nothing that should make it not work. Like, well, downloads. There's nothing on the downloads. Uh, okay, now it's working. Okay. Ow, 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 ow. Light shining on clean metal surface can cause electrons to be emitted from the surface. This is called photoelectric effect. This only happens if the energy frequency of the light exceeds a certain threshold. Increasing the intensity of the light does not lead to emission of electrons. Only increasing the energy up to the threshold value results in the emission of an electron. Increasing the density of light does not lead to emission of electrons. Only increasing the energy up to a threshold value resulting in this emission of electron, but above the energy threshold, increasing the light increases the number of electrons. Okay. This can be explained in a way that a certain amount of energy is needed to overcome the attractive forces holding the electron within the metal. If the energy of the photon striking the surface exceeds the value needed for the emission of the electron, excessive energy is converted to kinetic energy, determining the speed of the electron photon. From what I understood, light has a threshold. Like the photons have a threshold for holding energy. Increasing energy. Okay. So there's a threshold for how much light can act. Okay, I understand. So should I write those? The understanding of structure of an electron cell is closely related with the analysis of electromagnetic radiation that is either emitted or absorbed by matter. The following theoretical experimental considerations, which are discussed in the following slides, are regarded as essential for the understanding light emission from hot objects, black body radiation, spectral energy density, okay, wavelength and spectral energy density, kilojoule per cubic meter, nanometer. What? Mm-hmm. So they all start from the same wavelength, but higher the density, higher the temperature. Light emission from hot objects. Huh. Dude, I lost all my hands. Like, let me wash my hands. It's pretty cold. Oh. The graph you saw is almost certainly the blackbody radiation curve or Planck's radiation law graph, okay? What graph shows? It plots how much radiation energy an object emits at different wavelengths depending on its temperature. X-axis wavelength, spectral energy density, which means how much energy is emitted per wavelength range. Aha. Uh-huh. Okay. Dude, you're annoying out there. You stand there. Per range. What it looks like, the curve starts at 0, rises to peak, then falls again. Each temperature gives a different curve. Higher temperature peak moves to shorter wavelengths, bluer light. So a red hot object emits mostly in infrared and red wavelengths. A white hot object like sun emits across visible light. What it proved, the experiment showed that classical physics couldn't explain the shape of the curve. It predicted infinite energy at short wavelengths. You know, blackbody radiation graph shows how hot objects emit light energy at different wavelengths. How hot objects emit light at different wavelengths. Okay, objects that are hot at different temp. If it's really hot, it emits like literally white. That includes all the wavelengths. If it's red hot, it emits infrared. Uh huh. Uh huh. Mm-hmm. That's exactly the blackbody radiation curve was describing. Wien's displacement law. Okay, we're learning on new stuff, I guess. Each curve corresponds to an object at different temperature. 5000 Kelvin. Mm-hmm. The relationship between temperature and peak wavelength. Higher the temperature, smaller the peak wavelength. Higher the temperature, smaller the peak wavelength. Moves towards blue violet. I thought higher the temperature, hotter body emits more energy. The curve area increases. It emits higher frequency, shorter wave. Uh, higher frequency, shorter wavelength. Okay, that kind of makes sense. So shorter wavelength means more energy, if I understand. What was wavelength? Let me just quickly cross check. Mhm. Wavelength. The distance between two crests or trough. And shorter wavelength means more frequency. Yeah, that makes sense. Yeah, okay. Shorter wavelength means higher energy. Okay. These terms, shorter, when I hear short, I feel like, yeah, that's low. No, it's the opposite. Okay. That's why metal glows red, orange, white at is it hotter. So compare to the colors red, orange, white. It's increasing frequency. Frequency increases more waves per second. 700 nanometer wavelength, 620, 580, 480, okay. So when a hot object color changes from red to white, that means it's emitting higher energy light due to the increase in temperature. Okay, okay. I do have some questions on this part. So understand this on a physical. The white light photon or the photon that shows up as white light is vibrating more vigorously. Compared to higher wavelength. Photons does not vibrate, but the electromagnetic field that makes up the photon oscillates. Electromagnetic field. Oh, come on, neurons are not firing up. I I'm not getting a clear depiction of what electromagnetic field is right now up here, but okay. The frequency of the oscillation determines the color of the light. When you see a white light, the electric and magnetic field are oscillating much faster. Haha. Each photon carries more energy. Okay, that was right. When you see red light, the oscillations are slower. Uh, Why am I going into this deep? I don't know. I just wanna make sure I know this. Uh, could you explain this? I don't. Uh, I don't. Mm-hmm. What is electromagnetic wave? Light is an oscillating electric field. Okay. Perpendicular to each other. Think of it as two invisible waves moving together. Electric field up and down. Aha. Direction of wave propagation forward. That's why it's called an electromagnetic wave. What? I thought it was something. Okay. How frequency and wavelength affect distance between two consecutive peaks of the wave. How many peaks fast affects important? Light is an oscillating electric field and magnetic field. Okay, I did not know that. I thought light was its own thing. I thought, okay, so it's just so light is basically electric and magnetic field together. Could you explain where these electric electric fields produced by static charges or changing charges? A charged balloon creates a stationary electric field. Magnetic fields produced by moving charges. Ah, interesting. I did not. Maybe I'm stupid. I did not know light was actually made of electric and magnetic field. if we artificial a stationary electric field or a steady magnetic field does not radiate light. Light requires oscillating fields. If you have an electric field that oscillates, it generates a perpendicular oscillating magnetic field. That magnetic field in turn regenerates the electric field, allowing a self-sustaining EM wave that propagates through space. Antennas work on this principle. An oscillating current in the antenna creates oscillating electric and magnetic field which propagates as radio waves. Higher frequency oscillations, microwaves, visible light. So all these electromagnetic radiation, okay. Mm-hmm. Yeah, I don't know. Okay. So, how does the electric and magnetic field decides are they both deciding factor for the wavelength and frequency of the light form? Electric field and magnetic field oscillates together. In light, the electric field and magnetic field oscillate perpendicular to each other in wave direction of travel. The rate of oscillation of either fields determines the frequency of the light. Faster oscillations, higher frequency, shorter wavelengths. Okay, but which oscillation? The oscillation of electric field or magnetic field? Okay, it doesn't matter. One oscillation of E corresponds to one oscillation of B, so either field can be used to define the wavelength. So they both would be oscillating like equally. I don't know. It's so weird. Uh, out of the wavelength, right? The traumatic wave always in sync. Okay, they're always in sync. If electric field and different wavelengths or frequency, they would not reinforce each other properly. I don't know. I would like to see the how these. Yeah, it doesn't matter if the frequency is higher. When waves are self-sustaining, if the oscillations were out of sync, the feedback would fail and the wave would not propagate as a stable light wave. Key takeaway: you cannot have an EM wave where E has one wavelength. No, I'm not talking wavelength. I'm talking. Okay. Okay. I was. If one of the fields have higher crust and trough TR compared to the other, but the frequency and wavelength are same. Amplitude, yeah. Just mean electric field, okay, but the wave still propagates normally. In free space, there's fixed relationship. Uh-huh. Just changes the field strength. Mm-hmm. Bigger E crest, stronger electric field. Smaller B crest, weaker magnetic field. Wave still moves, but the energy distribution between E and B changes. Frequency or wavelength stays the same. So the propagation of light, or so this results in the speed of propagation of the photon. Okay, that is independent of the wave's amplitude. Okay. Oh, okay. Okay, so they just stay the same. Doesn't matter. E and B, the amplitude of electric or amplitude of electric field and amplitude of magnetic field stays the same, or they don't change. If E is larger, B also increases proportionally. Okay, but frequency, wavelength, and propagation speed remains as more energy per unit volume. Mhm. OBS, OBS, you stupid. OBS keeps on crashing. Ah, Lord. Not gonna lie, it's pretty fucking weird. Electric field exists as its own, magnetic field also exists as its own, but still they together form light. What? I need to look more into this later, not right now, but yep. Let me write these. Now, dude, my handwriting is the worst right now. What? Light? You kidding me? Generation 8, right? Somewhere like that. Oh, Lord. Yep, OBS crashed. OBS, you. OBS, what's wrong with you, OBS? What did I do? Why are you crashing? I don't get it. Why is OBS crashing? Well, I think I have to restart the computer after this session. Intensity of radiation. Hot objects emit radiation. Wavelength, frequency, color of the radiation. These observations could only be explained when assuming energy as a quantized parameter. Mm-hmm. How do I write this? So if I understand, uh, a hot object that emits light. Could you, okay? Okay. Could you briefly explain on the okay? There's only way to understand if OBS is working or not. The camera. Cool objects emit infrared, invisible to hot objects. Light emitted by hot objects depend on Clonopin Commander. I'm gonna refresh the chat because the site is pretty filled up. Yeah, perfect. Planck solved this by assuming E equals this means energy is emitted in discrete packets, not continuously. Uh-huh. But what so so after C by lambda, 1 by lambda. What's the unit for 1 by lambda? I don't know. Studying the spectrum of emitted light shows that atoms and electrons can occupy discrete energy levels. This observation laid the foundation for quantum theory and concept of electron shells. In short, hot objects emit light depending on the temperature. The higher the temperature, the lesser the frequency. Higher the frequency, lower the wavelength. Dude, I need to engrave into my mind frequency and wavelength. I just keep on higher the frequency, lower the wavelength. Yes. Uh, what structure of electron shell? How again? I did not understand how the emission of light by hot objects relate to the structure of electron shell. How are they related? Connected to the electron shells, if energy is quantized, means electrons in atom can only occupy certain energy levels. When an electron absorbs energy, it can jump to a higher shell. When it falls back, it emits light of specific wavelength. Okay. Summary: body radiation showed that energy is quantized. Quantized energy led to the idea that electrons occupy discrete shells rather than moving anywhere around the nucleus. So studying emitted light was one of the first clues that atomic energy levels exist. So first I have to write the black body radiation and how temperature is proportional to frequency. Yeah, temperature is proportional to the frequency of light emitted and inversely proportional to the wavelength. Yeah, and that proved that what is quantized. That proved that energy is energy. So the energy emitted by the black body is quantized. Is that what you? Stop, stop, stop. Oh, what? What? Where's the other Chrome tab? Fucking hell. Google sometimes disgusts me. I only search quantum, the electromagnetic wave diagram on Google. The next, right after that, I opened YouTube, and the first video I get was something related to quantum. Bro, Google, come on, bro. Stop making it obvious. You guys are making this too obvious. Obvious. energy can only be emitted or absorbed in quantities. They must. Frequency, right? No, wavelength. Is joules. Joules, joules, joules. That sounds like a name. This can be explained in a way that a certain amount of energy that is needed to overcome the attractive forces holding the electrons within the metal. If the energy of the proton striking the surface exceeds the value needed for the emission of the electron, excessive energy is converted to kinetic energy, determining the speed of electron. What is this?
When an electrode in an evacuated tube, as
Okay.
shown here, is coated with an active metal, electrons may be emitted from the metal when it is irradiated by light. This effect is called the photoelectric effect. Einstein explained the photoelectric effect by using Planck's concept of light as a stream of photons. When light of long wavelength impinges on the electrode, no electrons are emitted. Einstein proposed that this is so because the individual photons do not have sufficient energy to dislodge an electron from the attractive forces of the metal. Even when the light intensity is increased, there is no emission of electrons and no current flows. When light of shorter wavelength strikes the surface, electrons are emitted and are drawn to the anode. Thus, a current is seen to flow. Einstein proposed that the photons of shorter wavelength light impart sufficient energy to the electrons to enable them to escape from the metal. The kinetic energy of the electrons is the excess of that which they require to escape from the metal. When the intensity of the shorter wavelength light is increased, more electrons are emitted, and the observed current increases. However, the excess energy which the electrons possess remains the same. A higher intensity of light increases the number of electrons emitted, so the current increases. However, because each photon still imparts the same energy to each electron, the kinetic energies of the electrons remain the same. When light of still shorter wavelength is employed, the electrons are emitted from the metal with higher kinetic energy. This is so because the higher energy photons have imparted more energy to the electrons, and more kinetic energy remains after they escape from the metal.
Okay, so more shorter wavelength light or results in higher kinetic energy for the released electron. Mm-hmm. So how do I write all the information the screen to here? Body electrons are held in a shell. And when when it absorbs energy, the electrons jump to higher shells, and it'll release the energy in form of light when going back to its lower energy state or shell. Electrons cannot have arbitrary energy. Arbitrary. Arbitrary. Arbitrary energy. They occupy discrete energy levels. When an electron absorbs energy, it jumps to a higher energy shell excited state. When it falls back to lower energy shell, it emits energy as light, with photons energy corresponding to the difference between two shells. Uh-huh. Let me heat up my arms. It's getting cold. I'm still on the same page as last time. Come on. Come on, come on. Don't waste time. Okay. Fuck this. Okay, it's working. I was just checking if OBS crashed suddenly. Where's the mouse? Where's the pointer? I gotta keep on checking if it works. Was this wavelength or temperature? I don't remember. This was related to density of energy something. So lower wavelength, more energy emitted. Uh, what else? What else? From this, we were able to conclude that energy emitted or quantized back to its normal, back to its initial shell or stage. Like, let's say electron energy the electron moved from lower to higher energy state, and again when it loses energy, it releases light. I still have no idea why a photon is generated by an electron moving to lower energy state. Not gonna lie, that is pretty that is pretty fucked up. It is interesting. Yeah. Light. This kinda proved that electrons exist in a uh, exist in a what? Ah, fucking hell! I forgot the term. Structure of electron shell exist in energy based shells in the atom. And I have studied chemistry for 11 years or more. Yeah. I just found out like now that oh fuck that electric field and magnetic field together forms light. I did not know that, but I'm just new to this. But yeah, an electron shifting from higher to lower results in photon. And just like that, an electron could absorb photon and move to higher stage. Electron moving to higher state, is that ionization? I think it's on an atomic scale. I think that's being ionized, right? I believe it's called ionized. Uh, would that be considered as ionized? No, okay. An electron jumping to higher energy level is not considered ionization. Excitation, atoms absorb energy like photon. The electron moves to higher but stays bound to the atom. Okay. Okay, so if it loses, it's kind of. Okay, so if an ionized atom, that is, it has lost an electron, does it uh, emit light or emit photon when it receives the lost electron? Okay, it does emit photons. It feels like atoms are like factories for photons. They are designed to make photons. As it settles into the available energy level, it releases energy as photons. Hot objects emit radiation These observations could only be explained assuming energy as a quantized parameter. Okay, E equals HV equals HC lambda. Oh, also, Clonopin Commander. I also found out about the uh, going from bachelor's to PhD. There are, like, it is possible here. Yesterday I had some sort of career guidance, a Google Meet based on that, and have uh they did have institutes that offer PhD for students straight from their bachelor's, but the PhD is longer compared to students who are coming from their master's. So the PhD is going to be 5 years, fully paid. That's good, but you need an average score of 1.5 or below. Yes, the good grades. You need an amazing set of grades. And I think, yeah, the grades does matter anywhere. Like, one of the you can do it. Yes, I can do it. There's only one option. But yeah, like, one of the students that were there to do the meeting, they one of them got into Oxford, and they were like, yeah, Oxford looks into grades. Like, if you need to, if you want to continue the studies, it's better to have good grades. So yeah, and I am on the track of continuing, not like doing jobs. I mean, you need to have job to pay, but I gotta continue this. Hmm. Light shining on clean metal surfaces can cause. The problem is that a biochemistry degree without an advanced degree is low pay jobs. Once you had an advanced degree, you're worth much more. Okay. Yeah, I mean, I feel like I'm still scratching the surface for this course, and like, I make 120,000. That's a good amount. Respect. A year with my PhD, okay. And you get paid to study, right? That's really cool. Here also, from what I heard, they pay me to study. Yes, for a PhD, they will pay you. Yeah. But I think it's obvious. I'm still not sure which part should I follow. Like, I'm really into wet lab and dry lab, but I want to learn till I want to see how these two departments communicate. How does dry lab pick dry lab? You'll thank yourself later. Yeah, I mean, of course, dry lab is, I think it's a really important part of biochemistry, and I'm really curious on how this, dry lab and wet lab, how do they work? How do they communicate? I still have no idea how that. Maybe in the future I'll learn more. And I gotta say, dry lab was. It was. How do I explain dry lab? It's such a good tool, right? I think that's what dry lab is basically. It's a good tool to analyze huge huge amount of data. And yeah, I wanna go deeper into those. Light shining on clean metal surfaces can cause electrons to be emitted from surface. That's I read that more than 3 times. This only happens if energy or frequency of the light exceeds a certain threshold. Increasing the intensity of the light does not lead to emission of electrons. Only increasing the energy up to the threshold value results in the emission of an electron, but above the energy threshold, increasing the intensity of light increases the number of electrons emitted. Okay, could you I understood this part, but I want to write this into my notes on a much shorter scale. Could you brief. When applying low pressure, high voltages, gases emit light with different colors. Using suitable devices, this light may be split up into different lines. Line spectra from hydrogen led to hydrogen led to four distinct lines. Oh no, what is this? When applying low pressure and high voltages. When applying low pressure and high voltages, gases emit light. Mm-hmm. Aha, okay. It's a fact, and there you go. Gases emit light. You can do whatever with that information. There you go. When light shines on a clean metal surface, sometimes electrons are ejected from surface. This is called the photoelectric effect. Mhm. The light must have a minimum energy to eject electrons. Okay, there should be a threshold. I get it, no matter how. Okay. So here, the energy, are they talking about amplitude of the electromagnetic wave? Are we talking amplitude or frequency? No. Are we talking amplitude or wait. Again, frequency is the number of crest and trough on a wave, and wavelength is the distance between two. One has a length, that means the distance between two of those, and frequency is the number of ups and downs. Okay, one is the number of waves passing at a given point. The other one is the distance between two consecutive crest or trough. Increasing intensity. So are we talking about lower wavelength? Higher frequency? Minimum frequency, okay. So threshold is basically based on frequency. Hallelujah. So what are the things here? Uh, when light is shine, when light shines on a clean metal surface, electrons get ejected or emitted. It's called photoelectric effect. And there is an energy threshold. The threshold is based on frequency. This threshold frequency decides the photon's energy. Each photon carries an energy, but I read somewhere amplitude means higher energy carrying. But I also read that amplitude of the electromagnetic wave represents the energy carried. In classical electromagnetic theory before quantum physics, light is an electromagnetic wave. The amplitude of wave represents the strength of electric and magnetic field. The energy of the entire wave is proportional to the square of the amplitude. Wait. In classical electromagnetic theory before quantum physics, strength, the energy of the entire wave is proportional to a square of amplitude. So larger amplitude, stronger fields, more energy. But in this picture, energy is spread continuously, not in packets. Quantum view, when we look at light as photons, each individual photon energy depends on its frequency. The amplitude overall of the overall wave corresponds to how many photons there are, not how energetic each one is. Higher amplitude means more photons. What? How does the height of the crest results in more photons? Photons is the number of crests. How does the height amplitude matter when it comes to frequency, like to same frequency, but one could have higher amplitude. Is that right? I think it's right. Exactly, that is very sharp question. Shut up. You're absolutely right. You do. ChatGPT just glaze. It just glazes you left and right. Yes, King, you are right. You are right. You are always right, King or Queen. Frequency stays the same. If two EM waves have same frequency, that means their color is the same. each photons. So frequency fixes energy for photon no matter what the amplitude. Amplitude controls the number of photons. Amplitude control. Amplitude represents the strength of electric and magnetic field. The energy density of the light increases quantum terms, this corresponding to more photons per second. How does more photons? Whoa, what? So even though each photon still have same energy, you simply have more photons. I thought photons were a specific number of waves, that is frequency. I thought one photon means a specific number of EM waves. That is frequency. Think. In quantum, this corresponds to more photons per second or more photons per unit area. So could you make this sentence more sensible? Frequency of the electromagnetic wave determines the energy of one photon. Okay. The amplitude of the wave determines how many photons are present in the beam of light. How does amplitude show how many photons are there? If two beams have same frequency and one has higher amplitude, that beam simply contains more units, more photons per unit area. I get that the higher amplitude means more area covered, right? Yeah. That means more photons. I understood that same frequency, but one having on the graph, it looks like the one having higher amplitude takes up more space or uses more space to propagate. But how does that results in more photons? So more area they use. What does more photons mean? So my spelling result. Could you also explain what does it mean when there is more photons? What does that physically look like when there is more photons? I think more photons means brighter light, right? Yeah. First, what the graph really shows, when you draw two EM waves the same frequency but different amplitudes, the taller wave doesn't mean it takes up more space. It means that the electromagnetic field is stronger at each point in space and time. The height on the graph is just free field strength, not a physical size. And that is where, ladies and gentlemen, I have lost it, because I really thought the waves moved like this, but that was just a form of representation. Okay. Mm, field strength is means energy density. In electromagnetism, the energy stored in a wave depends on the square of its electric field strength. And magnetic field strength, the same. So a wave with twice the amplitude has four times the energy density. This is purely classical so far, no photons yet. Enter photons. When we describe the same light quantum mechanically, the frequency determines the energy of each photon. Okay, the intensity or the amplitude squared determines the total energy of the light beam. Mhm. To keep the math consistent between the classical and quantum picture, if total energy is higher but each photon's energy stays the same, there must be more photons in that beam if the total energy is higher. So a higher amplitude wave means a denser stream of photons. What does more photons physically means? Photons are quantized packets of electromagnetic energy. You can imagine a beam of light like a stream of tiny energy bullets. Low amplitude photons are spaced out, fewer per unit volume or time. High amplitude photons are packed more closely, more per unit volume or time. If you could somehow see this, the brighter beam would have higher photon density. Okay, I was right on that. Why does brightness or intensity increases with amplitude? Not because each photons gets stronger, but because there are more photons. I still have some questions. What higher amplitude means more photons per session or per. Okay, I get that. And the frequency controls So what is the real difference when it comes to higher amplitude with the same? That is exactly the right. Oh, come on. When it comes to amplitude equals brightness. Wait. Come on. Mm, mm, do I need to know this based on a torch? Okay. Could you explain this on the basis of photon emitted by the electron when it goes down to lower energy state? Like which scenario gives higher number of photons and which gives lesser number of photons even though the the frequency remains the same? When an electron drops to a lower energy, each time one electron drops from a higher energy to lower one, it emits one photon. The energy of that photon is fixed by difference between two energy levels, so the color of the emitted photon depends only on the energy gap, not how many electrons are doing it. Okay, how the number of photons change. Now imagine you have atoms, each with electrons that can make the same transition. Well, if a few electrons drop, a few photons are emitted. Many electrons drop, many photons are emitted. In both cases, the frequency of photon, okay, frequency stays the same, but the energy gap between the levels not change. Okay. Uh, Connecting to wave amplitude. Brighter light, dimmer light. The amplitude of the total emitted light. Think of a concert crowd. Nah. Again, okay. I want to know more on this. Okay, could you let me know why or on which scenario let's say uh, the brighter and dimmer light is emitted by two same atoms or identical atoms, what would be the or what different form of energy is supplied that one emits more photons than the other? Don't tell me brighter light. Okay. Don't tell me the answer that I'm thinking. Each atom has the same set of energy levels, so any electron transition between two. What determines the number of photons? Even though atoms are identical, the number of photons emitted depends on how many electrons actually take the transition. What decides how many number of electrons take transition? Number of electrons excited. Yeah, if electrons, how how do you decide the number of electrons excited? The amount of energy supplied. Suppose you shine light or heat on the atom, stronger energy input excites more electrons, more photons. So, more photons means more energy. Huh? Huh? Heating the atom, shining UV light, applying an electric field, okay. So, that does higher amplitude means more energy as more photons are supplied. As more energy was used up in the first place for the electrons to get or used up in the first place for more number of electrons to get excited. I don't know why I'm going this far. Maybe I'm stupid. Excited. No, maybe I'm stupid. I need to ask every sort of minute question. Connecting between energy inputs and amplitude. Why are you agreeing with me? To excite electrons in atoms, you need supply energy. More energy supplied, more electrons get excited. Yeah, makes sense. With these electrons fall back, each emits one photon of same energy frequency. While amplitude increases, amplitude of the resulting electromagnetic wave represents the total energy carried by the wave. Amplitude of the resulting electromagnetic wave represents the total energy carried by the wave. Okay, since each photon has fixed energy, more photons, more total energy, higher amplitude, so higher energy input, more excited electrons, more photons, higher amplitude, brighter light. Fewer photons. Again, so my question was, so how is that for the electrons to be emitted, they emphasize more on frequency than amplitude. To remove an electron completely from a metal, the photon must have enough energy to overcome the work function. This is independent of amplitude. No matter how bright the light is, if the photon energy is below the threshold, electrons won't be emitted. Amplitude just increases the number of photons. It's not their ability, but I just read oh no. I just read that amplitude literally relates to higher or more energy. It was true in a classical sense, but in a quantum picture. Uh-huh. Classical view of amplitude. In a classical electromagnetism, light is treated as a continuous wave. Amplitude represents the strength of the electric and magnetic field. Energy density of the wave is proportional to the square of amplitude. So higher, okay, that's the classical view. Light is made of discrete amplitude now corresponds to number of photons. Higher amplitude, more photons, more total energy. And why is individual photon matter? Why does individual photon matter for the photoelectric effect? My spelling, oh, individual? Electrons in metal are bound by the work function, the minimum energy needed to escape. To eject an electron, a single photon must carry at least this energy. Okay. So you give in photon, it ejects electron. You give in electron, it ejects photon. Mm-hmm. I still don't understand what's happening up there. I it's working, right? Yeah. I don't know. Maybe I'm a bit stupid. Maybe I was a little bit stupid. But why though? Why though? Yeah, I still don't understand how, in case of emitting electron, frequency is the one that matters. Could you could you explain what's happening as y is only frequency the deciding factor? Now the worst part is I'm talking to ChatGPT, which is an AI chatbot. I don't even know if this is saying the truth. That's the another worst thing. I'm actually scared if ChatGPT is gaslighting me, because you never know. You never know. You never know. Uh, Electron and metal are bound to atoms by a certain amount of energy called work function. Think of it like a hill. Electron is in a valley, must get enough energy to climb out. Okay, I get that. Photons hitting the electron. Light is made of photons. Each the energy is all or nothing for that photon. Either it's enough to overcome the work function or it's not. Why is each photon matter? Like what if two photons deliver the energy of the single photon that overcomes the work function? What? That just don't work. That's what they're saying, but why? Maybe we don't know. I think we don't know. That's the reason. I don't think it knows the answer. Could you explain how exactly the electron absorbs the proton? Mm-hmm. Photon is not a tiny particle of matter. It's a quantum of electromagnetic energy. It's a wave. It's a is this okay? Photons does not have mass or charge. It can transfer energy to an electron. From what I learned, electron is also a sort of wave. How is not, or is it a particle? When a photon interacts with an electron, as if the photon bounces off. So, in the case of mirror, is it like that? Like, I'm thinking too much. Photon of energy hits a metal surface. Electron in the metal interacts with the electromagnetic field of the photon. Mechanism inside an atom. Photon interacts with bound electron. If no energy match, the photon is not absorbed. Absorption is energy transfer. It's okay. I get that energy transfer, but so I also read. I'm going too far. I also read somewhere that electrons are also just waves. So does electron have frequency and stuff? Not stud, stuff. God damn it. One more question, and I need to write the rest of the answers. So it said that light does not have mass, but electrons do. But even though light does not have mass, it has the strength to eject an electron, or photons have the strength to eject an electron, but only a photon with threshold frequency, okay? Uh-huh. I don't know that part. It's still foggy to me. Photons does not have mass, right? But it still can push out. Hmm. Not gonna lie. Oh, my brain is fucked up. It's so weird. It's so weird. This part is fucking weird. Yep, I need to take that break and continue with the sequence analysis. What else? What else do we had? Concept of matter waves. Okay, okay. Quantum mechanical treatment of atoms. Quantum mechanical treatment of atoms. Principal quantum number nodes. Angular momentum. Magnetic quantum number. Orbitals. Okay, we are discovering a lot. Okay, well, I'm gonna take that break and we will be back in about 30 minutes or 1 hour. So, that's it for today. YouTube will continue with sequence analysis. Peace out.